Okay, in our previous video, we talked about why tensor operations are needed, right, in neural networks. Now, in this video onwards, we'll start working on different kinds of tensor operations we can perform in neural networks, because in different scenarios, we need to work with different kinds of tensor operations. So we will start with the reshape and the transpose operation, then slowly we move on to the different other operations over there. Okay, now before we start working on this reshape operation, let's start with a problem statement. We will try to solve this particular problem with these two particular operations, reshape and the transpose operation. So the problem statement is something like this one. So let's say we have 4 images stacked like this one, okay, one by one, 1, 2, 3 and 4. So now our aim is to, when let's say in some scenarios we need to feed the neural network these images but in a different way. So let's say we want to place this image something like this one, side by side, 1, 2, 3 and 4. So basically from a stack of images we want to create a single image by keeping these images side by side. Okay, so that's our problem statement. Now we will see how we can do it with these different tensor operations over there. Now before we do that, so let's talk about, or basically recap, what we learned in my previous video on different kinds of tensors called the 4D tensors, because over there we discussed how we can express a particular image using a 4D tensor, basically list of images using a 4D tensor. So let's say we have a image something like this one. So this is the same image I have discussed in that video as well. So in terms of dimensions, we have the width, we have the height, and if we just go by a very basic operation, so for each and every pixel we will be having the color depth, right, in RGB format. So let's keep it very simple over there. So this particular image, we can visualize it something like this one, where we have for each and every color, let's say red, green and blue, we have basically drawn these 3 planes over there, right? So this is basically depicting our color depth, and we have the height and width. So if you see it over here, it has 3 dimensions, right? The height, the width and the color depth. So this is basically nothing but a 3D tensors. We have discussed it over here. And if we have multiple images, we will be having multiple 3D tensors stacking one after another, right? So that means kind of like rectangular blocks. We are basically keeping one on top of another over there, right? So now when we have multiple images, if you see the different image samples also form another dimension called the 4th dimension over here. So if you have seen that particular video where we have discussed, like, the samples actually create another dimensions over there, right? So basically, so now the list of images or a number of images, we can express it as a stack of 3D tensors over there, something like this one, a list of rectangular blocks over there. So but the single image, we need to keep in mind that the single image is always a 3D tensors. We can always express it as a 3D tensors over there. Now with this idea, how we can express this guy over here. So as we saw in the previous slide, for each and every image we can do something like this one. So the image number 1, we have these 3 layers for RGB, so we can express it something like this one. Then for other images, we just need to stack one after another, right? So this one we can express it something like this one, where each and every image has their height, let's say a particular height, let's say 10, another particular height, let's say 10, width, let's say 10, and we have 3 color depths over here. So that means we are talking about a 4D tensor where we have 4 images. If you see it, 1, 2, 3, 4, and each and every image has a size of 10 by 10 into 3 over here. Okay, similarly, what about this guy over here? What will be the tensor? So what dimensional tensor we need to use it over here to express the final one? So let's think about this one. So this is nothing but a single image over here, right? So that means it has to be we can express it as a 3D tensors only, correct? So where each and every image will be keeping, we need to keep side by side, something like this one. And as we have seeing it over here, we are not stacking images over here, right? So that means we are not creating the fourth dimensions over here. Okay, now but let us try to see what will be the height and width of this guy, because over here each and every image has its height as 10, width as 10, color depth as 3. So let's draw the color depth for the final image. It will be looking something like this one. So we are kind of want to match with this structure with this guy over here. So if I just talk about the height, width and color depth of this guy over here, what it will be 20, because the height of the first image is 10, the next image is 10 as well. Similarly, the width will be 20 as well, because the width of the image 3 is 10 and image 4 is 10 as well, and the color depth is 3 over there. So that means this final product we can express it as a 3D tensor over here, where the height will be 20, width will be 20, and we have a color depth of 3 over here. So as it is a single image, we are not stacking images one by one, so that's why we do not have the fourth dimensions over here. Okay, so hopefully this problem statement is clear to us. So we are trying to go from a 4D tensor to a 3D tensor over here. Okay, so now let's talk about the reshape operation first. Let's see how it can help us to achieve this one. So the final one we may not be able to achieve by only using the reshape operation. We have to use the transpose operation as well, but we will start with the reshape operation and try to understand it thoroughly and see how it can helps to solve the current problem we are having it over here. Okay, so now let's basically, so what I did it over here is to understand the reshape operation. So each and every layer of that particular image, of a particular image, I just express it is a very simplistic way. So I just taken the first 4 pixel it over here for the first 2 rows over here. Okay, so this will be our red pixels matrix over here, something like this one, right? And this will be our green one, and this will be our blue one. Okay, I just give some variables, let's say ABCD over here. It can take any value over here, right? Depends on how much red, green or blue that particular pixel is having it, right? So that means it will be looking something like this one. So this is our image in a very, very simple form. So I just make it as a very simple form over here, right? So now if you are aware about NumPy or TensorFlow, we can basically create this kind of structure using a NumPy array over here. Okay, 3D structure. If you see it, this particular array is having 3 elements over here. Each and every element is a matrix of 2 by 4. It has 2 rows and it has 4 columns over here. Okay, so that is the way of creating a 3D tensor in NumPy. A similar thing available in TensorFlow as well. So when we'll talk about TensorFlow and other stuff, we will be coming back to this same stuff over there as well. Okay, but for now, this is the way we will follow the NumPy way of creating arrays over there. Okay, now if you remember, when we discussed about different kinds of tensors, we talk about very 2 different stuff. One is the shape of a tensor, another is the size of a tensor. These are very 2 interesting and important properties of a tensor. Now let's recap. So the shape of a tensor is, so basically when we talk about a 3D tensor, it will be having 3 values comma separated for each and every value. So let's say over here we have 3 layers, right? Kind of this one. Each and every layer is a 2 by 4 matrix. So that is what it is telling me about this one. So we have a 3 dimensions over here, the height, the width and the layer wise dimensions over here. That the 3 dimensions we talked about for a particular image over there, right? So that is what it is talking about. So now if we just multiply this all these things together, so we will get the size of a tensor, which is nothing but the 24 over here, correct? So that means this 24 is also telling me we have total 24 elements in this particular tensor over here. Okay, so we saw how to express a particular image data using a NumPy array. Okay, basically we created a 3D tensor over here. Now let's see what reshape operation is, and if we just apply different kinds of reshape operation on this guy, how it will change its forms. So in a very simplistic way, reshaping a tensor means basically rearranging its rows and columns to match a particular target shape. That means from a 3D tensor you can create a 2D tensor, or you can go for a higher level tensor as well, 4D, 5D you can go as well, okay? Or you can create a 3D tensor to another 3D tensor over here as well with a different shape, okay? But we need to keep in mind a couple of things over here. We cannot alter the number of elements in the tensor, so that has to be same, the number of elements. That means we have 24 elements in our sample image over there, right? The sample 3D tensor over there, so we cannot alter that. The 24 values has to be there over there, okay? Now the values of that elements cannot be changed. That means that A, B, C, D, whatever values it is holding, we cannot change that one as well, okay? The third thing is the data maintains its layouts in the memory. That means the sequence of the data. So when NumPy or TensorFlow creates a particular tensor, it reads the data sequentially and then it fits that particular target shape, okay? And so once it did that, basically TensorFlow creates a new tensor with the requested shape, but it's pointing to the same data over there. And I think NumPy, it basically did not create a new array, it just give a separate view over there of the data, okay? So this is, we can say, the definition of the reshape operation. Now let's see on our data. So this is our 3D tensor, this is our shape, this is our size. How can we apply different reshape and see visually what's going on? So the way we apply the reshape operation is there is a reshape method over there, okay? So over there you can give some shape. So we are starting with the shape 3, 2, 4, correct? The 3D shape over here. But over here if you see, I have given 3, 8. Now couple of interesting stuff over here to be noticed over here. If you see the 3, I did not change it at all, okay? I just multiply this 4 and 2, make this 8 over here, okay? That means the last 2 axes I just combined it and make it as 8 over here, okay? So let's see first what transformation it is giving me. So that means, so when you talk about a shape 3, 8, it's nothing but a 2D shape over here. That means it will be having 3 rows and each and every row will be having 8 values. That means 8 columns over here, okay? So now how NumPy will create these things? So it will start reading from the first element, A, B, C, D, okay? So it will first get A, B, C, D, but it has to create 8 values. That means it will some kind of flatten this particular 2D structure into a single dimensional structure. That means it will be doing something like this one, A, B, C, D, then E, F, G, H, okay? Similarly for the next layer, it will be doing the some similar stuff. For the third layer also it will be doing the similar stuff. So if you see it, we were having a 3D shape. From there we basically created a 2D shape over here by using this reshape operation, by giving a particular shape over here, okay? Now another interesting stuff we need to see it over here is I did not change the axis sequence over here, okay? So I was basically multiplying the 2 and 4 over here. The adjacent axes I was just working with, okay? So in future slides we will see why this is important, because when you change the sequence of the axes, the image integrity will not be there. If you see it over here, all the red values are still together, or all the green values are still together, right? Similarly all the blue values are still together over here. So the image integrity is still over here. We can easily access all these values over here. Now before we move on, the same operation, the same stuff, this 3 comma 8, we can do it something like, so basically this is a 2D tensor, or we can say it's a matrix over here. Now the same stuff, we can do it something like this one, 3 comma minus 1. So what we are telling it, basically my first dimensions, it has to create the 3 rows, then it has to calculate what will be the value of this guy. That is what minus 1 is telling me. So that means the size of the tensor has to be divisible by this one. This is also we need to remember, because 3 into 8 is also 24. So we are not changing, or we are basically not changing the shape or the size of this particular, we are changing the shape, but we are not changing the size of this particular tensor over here. We need to keep in mind that one, because in the definition we saw that one, right? So this particular operation means the same. Only thing is that the numpy is automatically calculating the value of 8 over here, because it basically divides this 24 by 3 and it calculates the 8 over here, and it creates the similar structure over here. So you can do something like this one as well, okay? But it's more on the program level, but the internal structure is always same over here, okay? Let's see another example. Now let's see what about this one. So when we try to do a reshape of 6 4, first thing we will see whether we are altering any axis or not. If you see over here, what I have done it, I just multiplied this 3 and 2. That means I have combined the first 2 axes over here and keep the 4 intact, okay? So ideally it should not change the image integrity as well. That means the red values will be still together, something like this one. So if you see, it is again a 2D shape, but it is having the 6 rows and the 4 columns over here. So it will be something like this one. So for each and every layer, we are already having the 4 columns over here. That means it will be keeping this layer like this one, right? So it is creating the 6 rows, and each and every row is having the 4 values over here, okay? So this is also a 2D tensor we created from a 3D tensor. And it's in the same way you can pass minus 1 to any of it over here, so that numpy or TensorFlow will automatically calculate the other dimension value over there, okay? So we saw 2 examples of how to create 2D tensors from 3D tensors, and while doing that we also discussed how keeping the axis, so how we need to work with the adjacent axes so that the image integrity will be intact. Now let's talk about this guy over here. If you see it, so we just did 4 comma 6. That means I multiplied this 3 into 2, okay? Then I just shift this 4 to the first position and 6 to the second position. That means I am playing with the axis position over here. Now if you see the final image it has created over there, the final tensor it has created over here, something like this one. And if you see it over here, how it has created this structure over here. So we need to, this is again a 2D tensor, right? So where we will be having 4 rows and 6 columns. So how it will be doing, it will start reading from ABCD, right? It get EF over here because it has to create 6 columns over here. For the next row it picked up this guy G and H, then it picked up the other 4 values from the next layer over here. If you see, it is mixing the other layer values in this particular layer over here, okay? So this is not the best way to use reshape over here. That is what it is, even though it is allowed, but it is not the best way to use reshape method over here, okay? So we need to keep in mind this one. So we need to keep in mind the axis. So we need to always work on the adjacent axes over here so that we don't change the image integrity over here, okay? Now let's see another example over here, bad example of 2 3 4. So what we have done, I just bring this 2 forward and bring this 3 to the second position over here, okay? Same way it has created another 3D tensor over here, if you see, because the size itself is telling me it's a 3D tensor over here. So where we'll be having 2 matrices, if you see it over here, each and every matrix will be 3 comma 4 size. That means 3 rows and 4 columns over here. So it will be started doing the similar way. So when you talk about 3 rows and the 4 columns, that means A B C D E F G H will be the part of it. because for the third row it will go to the next layer and it will bring up this guy over here. And if you see again, it is getting mixed over here. Okay, this is also not the best way to use the reshape over here. Okay, even though it's allowed over here. So now let's see another example, good example over here. If you see it over here, we are trying to create a 3D tensor, basically a 4D tensor from a 3D tensor over here. Okay, so 4D tensor means a multiple layers, there will be more than one multiple layers over here, correct? So that means over here, if you see what I have done, I just keep intact the 3, keep intact the 2 over here, but this 4 I divide into 2 over 2. Okay, so that means I will be having 3 elements in this particular array. Okay, each and every element will be having basically 2 matrices of size 2 over 2. That is what it is telling me over here. And if you see, it has created in similar way. So this is our whole array. It is having 3 elements. If you see, I have grouped it over here. Each and every element consists of 2 matrices of size 2 over 2 over here. Okay, the same thing I have picturized over here as well. So this is how it will be creating. So first it has to create 2 by 2. That means it will be dividing this A, B, C, D into A, B and C, D. Okay, then for the second row also it will be creating E, F and G, H, and it will be stacking them together to create the first element. Okay, so that means for the first layer we basically created 2 matrices over here. Similarly for the second layer, similarly for the third layer over here as well. Okay, so that means it's a 4D tensor over here. So now another thing, let us discuss over here. Now what will happen if we just give some reshape values which does not fit, because reshape has to keep the size of the tensor as is, right? So if I just give a reshape something like 5 comma minus 1, what will be happening over here? As 24 is not divisible by 5, so it will be throwing me some error, because it cannot determine the next, it has to be integer over here, right? So as 24 is not divisible by 5, so it won't be able to create the second value over here. So that's why it will be giving something like cannot reshape array of size 24 into shape 5 into new axis over here. Okay, so we need to keep in mind this one as well over here while reshaping it. So we got a fair idea about what reshape do. Now let us get back to our problem. Okay, so what in our problem, what we are trying to achieve from this 4D structure, we want to achieve this 3D structure over here, correct? So from a 4D tensor of size 4, 10 over 10 over 3, that means there are 4 images, each and every image will be having this size, with an image of size 20 over 20 into 3, correct? Because this full image will be having 3 layers, and this image height will be 20, width will be 20 as well over here. Okay, so now this guy over here, can we do a reshape? Okay, but before that, so let us first reason it through, because if you see it over here, we need to reach 20 over 20 over 3. Okay, so now if we can just play around with these numbers over here, if some way we can get 20, okay, we will be able to do the reshape over here, correct? Because as we have seen, if we can combine or divide adjacent axes over here. Okay, so some way from these numbers we are not getting 20 over here, because it's 4, 10 and 3, nowhere we can get 20. But if we can make this 4 is 2 into 2, there are 2 2's we will be getting it over here, and 10 into 2 is 20. So somehow we will be getting close to the final one. Okay, so let's see that. So now if I just do a reshape operation something like this one, so what I did, I just keep intact all the other stuff over here. I just split the 4 into 2 over 2. Okay, as we have seen it multiple times before, we are not interchanging any axis over there. That means we will be not be changing the image integrity, or we will be basically not mixing up image layers or different images together over here. Okay, but the thing is, if you see it, it is having 5 elements. That means it will be creating a 5D tensor over here. So how a 5D tensor will looks like? So if you if you just see the final product after this particular reshape, so this 1 and 2 will be together, okay, then this 3 and 4 will be coming up in like this one. So that means this, there will be two images stacked together, and on that particular, after that, side by side, this 3 and 4 images will be also stacked together. Okay, we reach somehow this structure over here. It is still not our final structure, but we are able to getting close over there, right? So, and this is a 5D tensor because each and every series will be a 4D tensor, and we will be having multiple series. That means it is a 5D tensor over here, correct? So that means we moved from a 4D tensor to the 5D tensor over here. So at least we are able to create these numbers 2, 2, 10, 10, 3, and also at least able to make two images stacked together side by side. Okay, so now, so if you see it over here, we are able to create this 2, 2 and 10, 10, 3 over here, and we know 10 into 2 is 20 over here, but this 10 and this first 2 is far apart. It is not the side by side axis over here. So, and I cannot use reshape over here to bring this 10 forward, because it will basically, the image integrity will be lost in that case, right? So we need to think about something else before we do the reshape over here. So that will be transpose, which we will be discussing in the next video. Okay, and another thing is that in our final image we have 1 and 2 side by side, not 1 and 3. That means this 2 has to be come over here, this 3 has to go down, and 4 has to go down over here as well. Okay, so we will see how to do that one as well. Okay, so in the next video we will talk about the transpose operation. Okay, then we will start, we'll be resuming how to fix this guy over here to get the final image. Okay, so hopefully this video was helpful. See you in next video.